Come on, my dears. Today let us finish all these sums from exercise of chapter number 6. Please kindly read this statement of first sum in the exercise, chapter number 6. Come on, read it. Look, they have given one graph in the statement. What is that graph? It is a graph of binding energy per one nucleon versus atomic mass number. EBN versus A, correct? Binding energy per one nucleon versus atomic mass number, correct? Fine. The graph is this. Fine. And on this graph, there are three nuclei which are shown by symbols Z, Y and W. Okay, fine. Now tell me, for Z nucleus, what is binding energy per one nucleon? They have given in the graph 5 million electron volt per nucleon. Correct? Come on, its atomic mass number is 30. For Y nucleus, binding energy per one nucleon is 8.5 million electron volt per nucleon, and for Y nucleus atomic mass number is 60, correct? And for nucleus W, binding energy per one nucleon is 8 million electron volt per nucleon versus its atomic mass number is 120, correct? What do you mean by atomic mass number? It is total number of protons and neutrons. That is total number of nucleons. Correct? Fine. The first process they have given is Y gives 2 times Z. Y gives 2 times Z. Fine. Now they have asked in which of the two given processes energy will be emitted. That is what we have to find out. Let me show you one very easy idea. You just find out Q value of the reaction, and if that Q value of the reaction comes out to be positive, greater than 0, then energy is liberated or energy is emitted. Okay, but if Q value comes out to be negative, less than 0, meaning thereby energy is absorbed. Okay, so let us see what is the Q value for this particular reaction. What is the formula for Q value of reaction? The formula is Q equals to EF minus EI. That is total binding energy in the final condition minus total binding energy in the initial condition. Final means after the reaction, initial means before the reaction. Correct? Fine. Now to find out total binding energy in the final condition, what you should do? You should multiply binding energy per one nucleon with a total number of nucleons. For Y nucleus, what is binding energy per one nucleon? It is in the final condition you are looking for final condition. Finally means this, correct? And finally which nucleus you have? Z nucleus. For Z nucleus, what is binding energy per one nucleon? It is 5 million electron volt, correct? And multiplied by total number of nucleons. In one Z nucleus, how many nucleons are there? 30 for one Z nucleus. But how many Z nuclei in the final condition? 2 Z nuclei. So I must multiply by 2, correct? Fine. So this is binding energy per one nucleon, and this is total number of nucleons, correct, in the final condition, minus total binding energy in the initial condition. In the initial condition you have Y nucleus. For Y nucleus, what is binding energy per one nucleon? It is 8.5 million electron volt per nucleon multiplied by total number of nucleons in nucleus Y. In nucleus Y, what is the total number of nucleons? It is 60, correct? So I am multiplying by 60, correct? Fine. Here only Y is there, only Y means single Y nucleus. So multiplying by 60. Suppose there are 3 into Y, suppose there is 3 into Y, suppose, then you may multiply by 3 here, okay? Simple? Fine. Now 30 into 2, that is 60 into 5, that is 300. Minus 8.5 into 60 comes out to be 510. 300 minus 510, that is minus 210 million electron volt. Tell me, in this reaction, Q value of the reaction comes out to be negative. Negative means less than 0. Q less than 0. So just now I told you, whenever Q value of reaction is less than 0, energy is absorbed. Okay. So I written here, energy will be absorbed, correct? Now second process, they have given W gives 2 times Y nucleus. Come on, W means initially and here 2 into Y, that is finally. Now let us find out Q value of this reaction. What is the formula? Q equals to EF minus EI. Final binding energy minus initial binding energy. Come on, total binding energy in the final condition. It is, in the final condition, there are 2 Y nuclei. Come on, for Y nucleus, what is binding energy per 1 nucleon? It is 8.5 million electron volt per nucleon multiplied by total number of nucleons. For 1 Y nucleus, total number of nucleons is 60, and for 2 Y nuclei, the total number of nucleons will be 60 into 2. I repeat. This is binding energy per 1 nucleon for Y nucleus multiplied by total number of nucleons in the final condition. In the final condition, you have 2 Y nuclei. For 1 Y nucleus, the number of nucleons is 60 and there are 2 Y nuclei, so I am multiplying by 2. Simple. Minus EI, that is total binding energy in the initial condition. Come on, in the initial condition, you have nucleus W. And for W nucleus, binding energy per 1 nucleon, it is 8 million electron volt per nucleon multiplied by total number of nucleons in nucleus W. For nucleus W, come on, total number of nucleons is 120. So I just multiply by 120. Correct? Here it is single W. Single W. Suppose they give 4 into W. Suppose 4 into W. Then this number you can multiply by 4. Simple? Fine. This multiplication is 1020, this multiplication is 960, this minus this comes out to be 60 million electron volt. Tell me, this Q value of reaction is positive, greater than 0, Q greater than 0, then come on, energy is emitted. Energy is emitted, okay? So just remember, just find out Q value of the reaction by the formula Q equals to EF minus EI. If Q value comes out to be positive, energy is emitted. Q value of the reaction comes out to be negative, energy is absorbed. Correct? Fine. Now kindly read the statement of number 2. Read it? Come on. In the theoretical part of this chapter, we had studied about branched disintegration. Branch disintegration. Remember, in case of branch disintegration, the effective reductive constant is lambda equals to lambda alpha plus lambda beta. Now, don't you know formula of average life? Formula of average life is tau equals to 1 upon lambda. If tau equals to 1 upon lambda, then what is lambda? 1 upon tau. So lambda alpha I can write 1 upon tau alpha plus lambda beta I can write 1 upon tau beta. You know what is tau alpha? It is average life during the emission of only alpha particles. Come on, this is average life during the emission of only beta particles. Correct? Now, one as it is, this average life they have given 1600 year, and this one as it is, and this top beta, they have given 400 year, correct? Fine. Now tell me, 1600 and 400, so LCM will be 1600, here it is 1 only, and 1600 upon 400, that is 4, you can just multiply by 4 here, 4 plus 1, that is 5 upon 1600, and now 5 upon 1600 comes out to be 0.003125, and remember, unit of lambda is always unit of reciprocal of time. And now in this example you are taking these 2 times in year, so unit of lambda will be year inverse. If you are taking this 2 time in hour, suppose, then you can write hour inverse. If you are taking this 2 time in minute, you may write minute inverse, correct? Right now we are taking this 2 times in year, so I am writing year inverse. Got it? Fine. M equals to m0 e raised to minus lambda t. M equals to m0 e raised to minus lambda t. This is, come on, exponential law for radioactive disintegration in terms of mass. Now what have they given in the statement? That in a particular time 75% of the element gets disintegrated. If 75% gets disintegrated, what is left in balance? 25%. Okay, fine. So if initial mass I take just 100 units, then what is its 25%? 25% of 100 is 25. So mass which is remaining undisintegrated is 25, correct? If initial mass is 100 units, then undisintegrated mass will be 25 only. Just to find out the value easily, we just take the value in 100 units. Initial value we take 100 units. Come on. 75% is getting disintegrated. So what is left? 25%. 25% of 100 is 25. Simple. Now into e raised to minus lambda t. Now transfer this 100 in the denominator. So 25 upon 100, that is 1 by 4. And this e raised to minus lambda t, if you just transfer in the denominator, then 1 upon e raised to lambda t, correct? Now take cross multiplication, come on. E raised to lambda t will be equal to 4. Simplify now further, take logarithm on both the sides to the base e, then power will become multiplier. So lambda t into natural log of e, and here natural log of 4. Now this lambda t as it is, natural log of e means log e base e, which is 1, and base e to base 10. If you want to transfer the value from base e to base 10, you must multiply by 2.303. So I am writing 2.303, correct? And into logarithm of 4. In physics, whenever ln is written, it is natural logarithm having base e. Whenever log is written, it is to be understood that it has base 10. Base e to base 10 multiplied by 2.303, correct? Now value of lambda we have found out 0.003125. 0.003125 into small t, which we require to find out, 2.303 as it is, and log of 4. In our log table you will get log of 4, 0.6021, correct? And now find out t, this into this upon this, okay? Answer is 443.72, this many year, because these 2 times you had taken in year. So final time is also obtained in year. Suppose they ask this time in second, then you have to transfer this value of time from year to second. For that you require to multiply by 3.16 into 10 raised to 7, correct? If at all they ask, okay? Now kindly read this statement of number 3. Read it? Come on, tell me what happens here. 2 protons, they are projected towards each other, correct? Along the same straight line, fine. And now there each of them has initial kinetic energy 18 kilo electron volt. Now naturally when they are moving towards each other, they repel mutually. And though they repel mutually, still they continue to go closer and closer. Naturally, at that time, they will require to do work against these repulsive forces. In doing that work, their kinetic energy will be utilized at one minimum distance between them. It will so happen that kinetic energy will become 0 for a moment. At that time, whatever is the distance between two protons, that is found to be minimum distance between them. That's why we call it distance of closest approach, and let it be shown by symbol R0, correct? Here what happens actually, when the two protons are very far from each other, they have initial kinetic energy 18 kilo electron volt, but when they come closer and closer, finally at the distance of closest approach, their kinetic energy has become 0. So there is a decrease in kinetic energy, but at the same time there is increase in electrostatic potential energy, because when they were very far, the potential energy was 0, and now at distance R0 between them, the potential energy formula is K Q1 Q2 upon R0, correct? So in this process, what has happened actually, kinetic energy decreases, potential energy increases. Then according to law of conservation of mechanical energy, we can write decrease in kinetic energy should be equal to increase in electrostatic potential energy. Fine. Decrease in kinetic energy is taking place. Decrease in kinetic energy is taking place for both the protons. So I need to multiply by 2. Total decrease in kinetic energy is for 2 protons. So I am multiplying by 2. And what is the initial kinetic energy of one proton? They have given 18 kilo electron volt. Convert it into electron volt, multiply by 10 raised to 3. And now convert electron volt into joule, multiply by 1.6 into 10 raised to minus 19. Correct? This is increase in electrostatic potential energy, and that should be equal to final potential energy, because initial potential energy was 0. What is final potential energy? By formula K Q1 Q2 upon R. Instead of R, I am writing R0, which is nothing but distance of closest approach we require to find out. Come on. This K value everybody knows, that is proportionality constant coming in Coulomb's law. It is 9 into 10 raised to 9 Newton meter square upon Coulomb square. And this, both the charges are of proton only. So if you take Q, then Q into Q means what? Q square. What is charge of proton? 1.6 into 10 raised to minus 19 Coulomb, and it's a square upon R0, correct? And now simplify, value of R0 you will get 4 into 10 raised to minus 14 meter, correct? Wait, don't write here R0 square. See, in the original formula it is not R square, it is only R, only R. In hurry, don't write K Q1 Q2 upon R square. No, this is the formula of potential G, where the formula is K Q1 Q2 upon R. Instead of R, I am putting R0, correct? Fine. If they ask in this value in Fermi, suppose, how would you convert it into Fermi? Come on, just multiply by 10 into 10 raised to minus 1. 10 into 10 raised to minus 1. Just multiply this by 10 into 10 raised to minus 1, which is 1 only. When you multiply by 10 here, it will become 40. And when you multiply 10 raised to minus 1 here, it will become 10 raised to minus 15 meter. And 10 raised to minus 15 meter is 1 Fermi. So it will be 40 Fermi, 40 Fermi, correct? Where 1 Fermi is 1 femtometer, which is 10 raised to minus 15 meter, correct? Fine. Now kindly read this statement of number 4. Read it? Come on. I equals to I0 into e raised to minus lambda t. This is exponential law for activity of a radioactive element. Now this is initial activity which they have given 16,000 count per minute, meaning thereby 16,000 disintegration per minute. So we are taking time in minute. After some time this activity reduces to 500 count per minute, that is 500 disintegration per minute. Now E as it is, e raised to minus lambda as it is, but because these two activities are taken certain number of disintegration per minute, then this time must be taken in minute. What is the time given to you? 4 hours. 1 hour is how many seconds, how many minute? 1 hour is how many minute? It is 60 minute. Okay. So we must convert this time from hour to minute, multiply by 60. Okay, fine. Remember, we are taking time in minute. And now transfer this in the denominator. So 500 upon 16,000, it gives you 1 upon 32. And this part, e raised to minus, this multiplication is 240, e raised to minus 240 lambda, if you transfer on the same side in the denominator, then 1 upon e raised to plus 240 lambda. Take cross multiplication, come on. E raised to 240 lambda will be equal to 32. Now take natural log on both the sides. 240 lambda into natural log of e. Here natural log of 32. 240 lambda as it is. Natural log of e means what? Log e base e, which is 1. And base e to base 10, you must multiply by 2.303. Come on. This 240 as it is. What is lambda formula in terms of half-life? Lambda equals to 0.693 upon tau half. And that equals to 2.303 into logarithm of 32 in our log table to the base 10. It comes out to be 1.5051. And now this tau half, if you want, you just make it subject of the equation. Find out tau half from here. It will be this into this upon this into this. Final answer is 47.98. This many minute, or this is nearly equal to 48 minute. Okay. My dears, this method I have shown here, which is a very general method. It will be applicable for any complicated values also. But so far this particular example is concerned, you may adopt another method which is quite short, quite easy. But because you are getting some power to the base 2, that value if you are getting, then you can apply this second method which is quite short and easy. Okay. But if you are getting any complicated value, then you must apply this general method. Okay. Let us see this second method now. You know, at the end of time equal to n times half-life, how much is the activity? 2 raised to nth part of initial activity. So I equals to I0 upon 2 raised to n. At the end of this much time, t equal to n into tau half. Come on, find out 2 raised to n from here. It will be I0 upon I. Come on, 2 raised to n will be I0 upon I. Now tell me, what is initial activity? They have given 16,000 count per minute. What is final activity? 500 count per minute. 16,000 upon 500 comes out to be 32. And don't you know 32 is nothing but 2 raised to 5. Correct? So if value of ratio of I0 to I, initial activity divided by final activity, if you are getting in terms of some integer power to the base 2, then this method is very effective, very easy, very short. Come on, match these two. Match these two. Base is same, so powers also must be same. N must be 5. Now tell me, when activity will become this much, provided the time lapse is n times half-life. What is the time lapse? They have given 4 hours, but 1 hour is 60 minutes. Come on, convert it into minute, multiply by 60. This n value we have found out, that is 5. And now because this time we are taking in minute, naturally tau half we will get in minute. And 16 to 4, that is 240, divided by 5 comes out to be 48 minute. Okay. Once again I remind you, if you are getting this ratio in terms of some integer power to the base 2, then only this method you can apply. Otherwise, this method is applicable, which is quite general. It is applicable everywhere. Okay, fine. Now read the statement of number 5. Read it. Come on. Number of moles of atoms mu equals to, you have studied 2 formula in 11th standard. Mu equals to n upon Na, and that equals to m upon m0 also. Come on. Activity formula. I or dn upon dt. What is the formula? Minus lambda n. I equals to minus lambda n. Take modulus on both the sides. So mod of I, and when you take mod, minus will become plus. Mod I as it is. What is lambda formula? In terms of half-life, lambda equals to 0.693 upon tau half. 0.693 upon tau half. Into capital N. What is capital N from here? M into Na upon M0. M into Na upon M0. M into Na upon M0. Correct? Fine. Now this 0.693 as it is. What about given mass? You are given, come on, 1 gram. 1 gram. And then if you are taking this mass in gram, this also must be taken in gram. Come on. Na is Avogadro number 6.02 into 10 to 23 atoms per mole. What about half-life? They are given 4.98 into 10 to 10 second. And because you are taking time in second, final activity should be represented in terms of certain number of disintegrations per second. And this mass, this is atomic weight. Which element is given to you? Radium 226. I told you in the past, whenever they are not giving atomic weight, you are supposed to take atomic mass number as atomic weight, but that many gram per mole. So this atomic weight for radium would be 226 gram per mole. And when you are taking this mass in 1 gram, come on, this also should be taken in gram only, so that gram will cancel. Come on, this mass is 226 gram per mole. I am writing here 226. Simplify, answer is 3.7 into 10 is to 10, that many disintegration per second. But don't you know, 1 disintegration per second is nothing but 1 becquerel. 1 becquerel. Fine. And 3.7 into 10 to 10 becquerel, it is nothing but 1 curie. 1 curie. Because 1 curie we had studied in theoretical part of this chapter. 1 curie equals to 3.7 into 10 to 10 becquerel. Whenever you require to convert any value of activity from becquerel to curie, you should divide by factor 3.7 into 10 to 10. Correct? So when you divide this value by 3.7 into 10 to 10, naturally you get answer 1, that many curie. Got it? Fine. Kindly read the statement of number 6 now. Read it. What is the given nucleus? 17, chlorine, come on, 35. Come on, match it with ZXA. Fine. What is Z now? 17. Z is 17, meaning thereby number of protons inside inside the nucleus of one atom of chlorine is 17. What about number of neutrons? By formula, N equals to A minus Z. This minus this, that is this minus this. 35 minus 17, answer is 18. So inside one nucleus of chlorine atom, there are 17 protons and 18 neutrons. Correct? Now find out first of all mass defect. Mass defect formula, delta M equals to ZMP plus NMN minus capital M. Just give me identification of each symbol. Come on, number of protons. MP is what? Mass of one proton in a free state. N means total number of neutrons in one nucleus. And what is Mn? Mass of one neutron in a free state. What is capital M? Mass of given stable nucleus. I mean mass of the given nucleus in a stable condition. Okay, fine. Now what is Z right now? Z is right now 17. Mass of one proton in a free state, they have given 1.00783 atomic mass unit. Number of neutrons we have found out, it is 18. Mass of one neutron in a free state, they have given 1.00866 atomic mass unit, minus this is mass of a given nucleus in a stable state, and that mass is given to in the statement 34.98 atomic mass unit. Fine. When all these masses are taken in atomic mass unit, naturally this delta M value will be obtained in atomic mass unit. This into this is this much, this into this is this much, minus this term as it is. Addition of these two values comes out to be this much, minus same value written here, and now this minus this comes out to be 0.30899, this many atomic mass unit. And now what is binding energy formula? Binding energy formula is EB equals to, remember, product of value of delta M in atomic mass unit multiplied by energy equivalent to 1 atomic mass unit. Come on, value of delta M in atomic mass unit, just now we have found out 0.30899 multiplied by energy equivalent to 1 atomic mass unit, which at present they have given 931 million electron volt. In the statement they have given, okay. Now this multiplication comes out to be 287.66969 million electron volt. Wait, this is binding energy of whole nucleus. We want now binding energy per one nucleon, that is EBN. It is nothing but total binding energy divided by total number of nucleons. Total number of nucleons means what? Atomic mass number, that is capital A. What is EB value? 287.66969. Same value written here, divided by capital A. What is atomic mass number right now? A equals to 35. A equals to 35. Come on, A equals to 35. Correct? Now this upon this comes out to be 8.219134 million electron volt per nucleon. Beware of the unit. Don't simply write million electron volt, because you are finding binding energy per one nucleon. You must mention this unit, million electron volt per nucleon. Got it? Now read this statement of number 7 example. Read it. We are asked to find out density of material of nucleus. Just consider one nucleus. The mass of one nucleus I am taking capital M, and volume of one nucleus I am taking capital V. Come on, mass of one nucleus means what? Mass of all the nucleons inside that nucleus. Average mass per one nucleon, suppose I am taking small m, I am multiplying by total number of nucleons, which is atomic mass number capital A. Come on, m into A, this product will give you total mass of one nucleus. And volume, come on, nucleus we assume to be spherical, and what is the volume of a sphere by formula? 4 upon 3 pi r cube. 4 upon 3 pi r cube. Got it? Fine. And now m into A as it is, 4 upon 3 pi as it is. But what is the formula for characteristic or average radius of a nucleus? We have studied in theoretical part. R equals to R0 into A raised to 1 by 3. R equals to R0 into A raised to 1 by 3. Whole raised to 3. Don't forget. Come on, m into A as it is. Come on, 4 upon 3 pi as it is. Come on, R0 cube. That's what I written here. But A raised to 1 by 3, whole raised to 3, 3 will cancel, giving you only A. And now this A and this A will get cancelled from numerator and denominator. Left in the numerator is only small m, divided by 4 upon 3 pi R0 cube. 4 upon 3 pi R0 cube. Now just substitute the values. What is this? Average mass of one nucleon, which they have given 1.0088 atomic mass unit. Convert it into kilogram. They have given conversion relation. Just multiply that value by 1.66 into 10 raised to minus 27 kilogram. I just multiply by 1.66 into 10 raised to minus 27. Got it? Divided by, come on, 4 upon 3 means what? 4 upon 3 is 1.333. Pi value is 3.14. What about R0? It is a constant. They have given in the statement as 1.1 Fermi. 1.1 Fermi. Fermi you must transfer into meter. 1 Fermi is 10 raised to minus 15 meter, and don't forget to make it's a cube. Okay, write power 3 here, and now simplify. You will get the answer nearly 3 into 10 raised to 17 kilogram upon meter cube. You know the SI unit of density, which is mass upon volume. For mass, what is SI unit? Kilogram. For volume, what is SI unit? Meter cube. density of material of nucleus comes out to be nearly 3 into 10 raised to 17 kilogram upon meter cube. Correct? Fine. Kindly read the statement of number 8. Read it. Come on, activity formula I or dN upon dt, it is minus lambda n. Take modulus on both the sides. So mod of I, when you take mod from minus, it will become plus. Now this is activity or rate of disintegration which they are given 8000 atoms or count per second. 8000 atoms or 8000 disintegration per second. Per second, so we are taking time in second now. Come on, lambda as it is. And when the rate of disintegration is this many disintegrations per second, at that time the number of undisintegrated atoms were, come on, 8 into 10 raised to 7. Find out now lambda. From here you will get it 10 raised to minus 4. I already told you unit of lambda is unit of reciprocal of time. Right now you are taking time in second. So 1 upon second, that is second inverse. Second inverse. What is half-life formula? Very easy. 0.693 upon lambda. 0.693 as it is. What about lambda? It is 10 raised to minus 4. Correct? Second inverse. And now tell me, this upon this, answer is 6930. That many second. Leave proper gap here and write perfectly small s and don't put any full stop. In hurry, if you are writing s and if it looks like capital, it won't look like capital S, but it will look like letter 5. Okay, number 5. So the examiner may read like something like 69,305. It is not like that. It is 6,930. That many second. So leave proper gap. Write small s perfectly. Don't put any full stop, please. Now read number 9. Read it? Come on. They have given this reaction. Come on, 2 deuterons are combining and that gives 1 helium nucleus, not helium nucleus actually, it's a isotope, 2He3, plus 1 neutron is emitted and this much energy is liberated, 3.27 million electron volt. Wait. Now just recall the formula, 2 formula for number of moles of atoms, mu equals to n upon Na equals to m upon m0. Find out n, it will be m into Na upon m0, m into Na upon m0. Come on, this mass is given to you as 1 kilogram of deuterium element, 1 kilogram. So if this mass you are taking in kilogram, this atomic weight also you must take in kilogram. This mass is given to 1 kilogram. What about Avogadro number? 6.02 into 10 raised to 23 atoms per mole and divided by atomic weight. What is the element given to you? Deuterium, for which symbol is this? 1s2. So now atomic weight will be 2 gram per mole. Come on, 2 gram per mole. But convert into kilogram per mole. 1 gram is 10 raised to minus 3 kilogram. So it is 2 into 10 raised to minus 3 kilogram per mole. Now this m0 value I am just substituting here. 2 into 10 raised to minus 3 kilogram per mole. Now 6.02 upon 2, it is 3.01 and this 10 raised to minus 3 going up will become 10 raised to plus 3. So here it is now 10 raised to 26. N equals to total number of deuterium nucleus, total number of deuteron nuclei or total number of deuterium atoms in a given element of 1 kilogram mass is, come on, 3.01 into 10 raised to 26. Total number of deuterium nuclei are, come on, 3.01 into 10 raised to 26. Wait. And now I am writing here number of deuterons and opposite I am writing energy liberated in million electron volt. If two deuterons are combining, that gives you this much liberation of energy. Come on, if two deuterons are combining, then that gives us emission of how much energy? 3.27 million electron volt. Then if these many deuteron nuclei take part in this, like the process which is mentioned here, come on, for this many number of deuteron nuclei, what will be the amount of energy liberated? Come on, for two deuterons, if they are combining, energy liberated is this much. Then if this many deuteron nuclei are combining, then what will be the amount of energy emitted? Let us find out. It will be this into this upon this. This into this upon this are written here, correct? And that energy I am showing by symbol E, that many million electron volt. Now this upon 2 comes out to be 4.92135 into 10 raised to 26 million electron volt, correct? Wait, convert this energy into joule. Million electron volt you must convert first of all into electron volt, multiply by 10 raised to 6, correct? And again you convert electron volt into joule, multiply by 1.6 into 10 raised to minus 19, correct? And now this multiplication comes out to be 7.87416 into 10 raised to 13, this many joule. Wait, now one bulb is given to you having electrical power, come on, 100 watt. What is watt? Watt is nothing but joule per second. So 100 as it is, watt is joule per second. What does it mean? If you supply 100 joules of electrical energy to it, it will run for 1 second. When we supply 100 joule and if the bulb runs for 1 second, then if we supply this many joule, then it will run for how much time? Let us find out. For 100 joules supplied to the bulb, it glows for 1 second. Then if you supply this many joule, it will glow for how much time? This into this upon this, correct? And that answer in second comes out to be 7.87416 into 10 raised to 11, this many second. But by chance if they ask this time in a year, then you know 1 year is 3.16 into 10 raised to 7 second. So going from year to second, you should multiply by this factor. But right now we require to convert value of time from second to year. Second to year, then you should divide by 3.16 into 10 raised to 7. Come on, I am dividing by 3.16 into 10 raised to 7. This upon this comes out to be 2.4918 into 10 raised to 4, this many year. 10 raised to 4 means what? 10,000. And if you multiply this value by 10,000, answer is 24,918 this many year. 24,918 this many year. Okay, fine. Come on, my dears. At the end of this chapter, I would like to discuss some very important points not directly given in the textbook. It will be worth solving because they will be again and again asked in the frequently in the examination, might be in the school, might be in the final examination in the form of extremely short question or might be in the form of MCQ. Okay, they will be very useful to you. Let us discuss such points. Point number 1 is this. Look here. You know formula of half-life, which is tau half equals to 0.693 upon lambda. Take this lambda up. So it is tau half into lambda will be 0.693. But tell me, 0.693 is constant. So tau half into lambda comes out to be constant. Now if you match this with y and if you match this with x, then this equation is something like x into y equals to constant. X into y equals to constant. Tell me, in mathematics, this equation x into y equals constant, it is nothing but equation of hyperbola. If it is equation of hyperbola, then graph of tau half versus lambda must be hyperbola. That's why I am showing graph of tau half versus lambda as hyperbola, correct? Because this is now equation of hyperbola, correct? Fine. Suppose I am writing the same equation this way. Tau half equals to 0.693 into 1 upon lambda, into 1 upon lambda and plus I am writing 0. Now I am plotting graph of tau half versus 1 upon lambda, not lambda but 1 upon lambda. So tau half on y axis and 1 upon lambda on x axis. Come on. Match this with y coordinate, match this with m, match with this x coordinate, match this with x coordinate and match this with c, and then you will find this equation very much like y equals to mx plus c, which is nothing but equation of a straight line having slope m and having intercept on y-axis equal to c, correct? If this is equation of a straight line, then you may say graph of tau half versus 1 upon lambda must be straight line. Come on, graph of tau half versus 1 upon lambda, you can see it is a straight line. Not only that, whenever c equals to 0, that graph is passing through origin, okay? For such a graph, what is the slope? Slope is m, and that m is right now, come on, 0.693. So slope is m, and that m value is right now 0.693, okay? And because it is a rising graph, slope is positive, For a falling graph, slope is negative. For a rising graph, slope is positive. Come on, everybody knows exponential law for radioactive disintegration, n equals to n0 into e raised to minus lambda t. Now, come on, take natural log on both the sides. So, natural log of n, if you take this as a, take this as b, then it is a into b, and its natural log would be natural log of a plus natural log of b, like that. If you find out here, then natural log of n0 plus natural log of this, that is, come on, minus lambda t into natural log of e. This power will become multiplier. Now, this natural log of n as it is, this is natural log of e, which is 1, plus minus lambda t I am writing first, and later on I am writing plus natural log of n0. Now, suppose I want to plot a graph of natural log of n versus t. If I want to plot a graph of natural log of n versus t, then let me take this on y-axis, then it will be compared with y coordinate. If I am taking this time on x-axis, then I should compare it with x coordinate. Minus lambda I just compare with m, and this part natural log of n0 I just compare with c. So, this is the equation very much like y equals to mx plus c, and don't you know y equals to mx plus c is nothing but equation of a straight line having slope m and having intercept on y-axis equal to c, correct? Now, tell me, graph of natural log of n versus t, you can see it is a straight line, but why I am showing falling graph, why not rising graph? Because slope is m, and that slope is how much? Minus lambda. Slope is m, which is, come on, minus lambda. If the slope is negative, you must show the graph as a falling graph. That's why I am showing you falling straight line, okay? Not rising graph, but falling graph, because slope is negative. Fine. Now, come on, let us plot two curves, one for parent element, another for daughter element. You know, in a radioactive element, as time passes on, for parent element, the number of undisintegrated atoms goes on decreasing exponentially, and for daughter element, number of undisintegrated atoms goes on increasing exponentially. Then for, come on, parent element, you will get decay curve like this, which is also exponential curve, and for daughter element, you will find such a growth curve, correct? Both of them are exponential curves. This is called decay curve, it is for parent element. This is called growth curve, it is for daughter element. And you can see they intersect at this very point. Suppose they ask in the examination the coordinates of this point of intersection. How would you find out? Very simple. This is the point where both the curves intersect. At that very point, this number of undisintegrated atoms has become exactly half of this number. If this number is n0, then this number is n0 by 2. Now tell me, at the end of how much time number of undisintegrated atoms becomes half? At the end of time equal to half-life. So if this number is getting reduced to half, then corresponding time interval must be equal to half-life, that is tau half, correct? So for this point of intersection, you can see its x coordinate is this much, which is tau half, but tau half formula everybody knows, 0.693 upon lambda, comma, y coordinate is this much. This much means how much? n0 by 2, correct? So this is x coordinate, this is y coordinate, got it? Come on, this become the coordinates of point of intersection of decay curve of parent element and growth curve of daughter element, got it? Fine. Leave this graph incompleted here, here also. Don't allow this graph to touch this time axis, and don't allow this graph to touch this horizontal line passing through this point. Okay, fine. Last point. Suppose I want to plot a graph of activity versus number of undisintegrated atoms. Come on, recall the equation of activity. I equals to minus lambda n. I equals to minus lambda n. I can write definitely plus 0, no problem. If I am taking this on y-axis, it should become y coordinate for me. If I am taking this on x-axis, it will become x coordinate for me. Match minus lambda with m, match this 0 with c. Then this is the equation of a straight line. So graph of I versus n must be a straight line. Graph of I versus n must be a straight line. But why I am showing in the fourth quadrant? Because n is the number which is always positive. But when this is positive, plus minus minus, activity is always negative. So which is that quadrant in which x coordinate is positive and y coordinate is negative? It is none but fourth quadrant. So this must be the graph in the fourth quadrant. And because c equals to 0, it is a graph passing through origin. Fine. And for such a falling graph, the slope must be negative, and the slope is how much? Minus lambda. Slope is m, which is come on minus lambda. Simple.